Resources. Most message processors in Mule are triggered when called via a previous element in a flow. Some connectors use or can use a polling process to actively retrieve messages from an external resource. These are things that we've seen like file, but also FTP and SFTP. If you want the other message processors to actively call a resource at regular intervals, you'll use a poll scope element. When you want to schedule a poll and drop the poll scope in, by default, a resource will be polled every 1,000 milliseconds or 1 second. There are two methods to change the polling interval. One is that you can use the fixed frequency scheduler, which is a pretty friendly way to specify a time unit, how long the delay should go for, and what the frequency is. And then lastly is the cron scheduler, which will allow you to put in your own cron expression that will specify when this poll should trigger. Now, sometimes when you're polling, it's helpful to use watermarks. So instead of pulling a resource for all of its data on every call, sometimes you'll want to retrieve the data that is newly created or updated since the last call. To do this, you need to keep state or some persistent record of either the last item that was processed or the last time the resource was polled. In the context of Mule flows, this persistent record is called a watermark. Now, how do these work? The first time the poll runs, the watermark is set to a default value that you specify. It is then used as a necessary when running a query or calling a resource. The value of the watermark may be kept or changed depending on the logic in your flow, and the value must persist across flows. So Mule uses a built-in object store for persistent storage and exposes the value as a flow variable. This means that when it's actually running at runtime, you'll access the value as a flow var, but deep down it's going to store it in a persistent store. It will either be saved to a file for embedded Mule and standalone Mule runtimes, saved to data storage if in Cloud Hub, or saved in the distributed shared memory if you're clustering Mules on premise. So let's pull our own resource. In walkthrough 11.3, we'll use a form to add accounts for a postal code to an accounts table. We'll create a flow with a poll scope as the message source. We'll poll a database every 5 seconds for records with a specific postal code. And we'll use a poll watermark to track the ID of the latest record retrieved, and use that watermark to only retrieve new records with that postal code. Let's get started. Let's head back to our student files and open up our snippets file that we've been working in through class. Let's search for the accounts list URL. So the accounts list URL. And let's go ahead and copy the account list URL from this text editor. And return to our web browser and paste that link into the web browser. Once that link has been pasted, you should see a form that looks something like this with a bunch of different potential accounts to be listed. This is where we're going to add some accounts in to pick up and bring through our system. Now be aware the accounts we add in here are going to be accessible to everyone taking this course, so don't put any personal information in when you're creating these accounts. Let's click Create More Accounts, and let's add a new record in with our specific postal code. So the name of this account will be Dale's Burgers, or Dale Burgers. We'll say street of 1234, and again, feel free to make up different criteria here. The city, and the postal code that you'll be using, and then hit Create Record. We can now go to View Existing Accounts, and inside of View Existing Accounts, along with some other test data I'd put in previously, I can now see the information here. So again, you're going to put in your own, but do be sure to not put in any personal information inside of here. Now, if we return to Anypoint Studio, now that we've got an account in place, let's set up a flow that's capable of polling a database. So inside of Accounts XML, we are going to bring in a new flow, but we're going to start it with a poll scope. So we'll drag the poll scope to the very top, and we'll rename this flow and call it Poll Database Flow. We'll select the poll scope, and with the poll scope selected, we'll set the frequency to 5, and very important here, be sure to set this to seconds so it doesn't try to poll every 5 milliseconds. Now, let's drag a database connector in, and in the process phase, we'll bring a logger in as well. That way we can debug more easily. So let's set up the logger to print out the payload so we have an easy way to sift through the payload we're looking for. Now, before we configure this database, let's get some properties in place that we can use. We will go back to examples-dev.properties and we'll bring in the DB host, port, user, password, and database. You can find these inside of your student snippets file. So again, that will be DB host, port, user, password, and database. So take a moment to copy these properties and paste them into examples-dev.properties. Once you've done that, come back to this video and we'll continue on. We'll go into the global XML, and from the Global Elements tab, let's add in a new database connector. So in this case, in fact, there should be a specific one for MySQL. If we search for MySQL up here, we can select the MySQL configuration. In the configuration, we'll put in those properties from our student file. So we'll do db host, we will do db.port, db.user, and db.password, and then lastly, our db.database. So it pulls out each respective property. Now, as we've seen before, in order for MySQL config to work, we will need to provide the driver. So we can hit add file for this driver. And inside of our student files, we can go to the jars directory, find the MySQL connector Java jar, and open that jar up. With the jar selected and added, we can also click test configuration, and in a moment, it should validate that the test was successful and come back with a connection good response. We can now hit OK and hit OK again. And now let's see if we can actually query this specific endpoint inside of our application. To do this, we'll save our global config, go back to the accounts XML, and double-click on the database in order to set up a query. Our operation is, of course, going to be a select statement. And inside of our box here, let's go ahead and put in a select all statement, specifically from the table labeled accounts. And we'll specify where the postal code is equal to our postal code that we had inputted. So this will be a string. You can put single quotes around it. And we will save up the configuration thus far. Remember, for each one it picks up on that 5-second interval, it should also log out the payload. So let's go ahead and run this project and see if we get any results back. Keep an eye on the logs. I've cleaned mine out here using the clear button. Every 5 seconds, I should see my respective records with that zip code be pulled and showed. So we're effectively pulling the database on this interval and bringing those objects into Mule so that we can do whatever we want with them, in this case, simply logging them. Now, what if we want to make sure that we don't continuously pull in the same messages? We want to persistently say, here's the last record ID I got, only get newer record IDs. Well, we can do this using the pull scope. So we'll stop our process, select the pull scope, and towards the bottom, you'll see the watermark option. Let's enable watermark, and we'll set a variable name of last account ID with a default expression of 0, saying the first time you query, use last account ID as 0. The selector in this case is going to be max, meaning it'll find the highest last account ID based on our expression, which will be to look inside of the payload specifically for the account ID field. So find the highest or maximum account ID number and then store that in the variable last account ID. So now that we've got this in place, we should be able to set ourselves up in order to use this. Now, one trick with polling is it will require our flow to be synchronous, meaning that the same thread is going to execute the poll and go downstream. That way we can ensure the watermark can be updated. We'll select the poll, and inside of poll we'll choose a processing strategy of synchronous to make sure that that persisted store is updated accordingly with our watermark. Now we're going to go ahead and see if we can get this last account ID to be respected. To see the last account ID, let's just put a breakpoint on the logger here at the end, and let's go ahead and debug the project. Once this picks up the first time, I expect the debugger to stop on this logger, and we should be able to see what the value of that watermark is and how we can effectively use it inside of our query. So now that it's deployed, we can see it stopped on the logger. I'll go to the debugger. And in the variables box, you can see it is exposed as last account ID. If we were to use our expression evaluator and put in something like flowvars last account ID, you can see that that value is able to be respected here. So what I'm going to do is, and I'll use the dot syntax that we've been using all along, both which will resolve just fine. I'm going to copy this expression from the evaluator since I know it's valid, and I'm going to use this in our query. So if I go back to the database query inside of here, and in the database query where we've got our where clause, we also add in an and statement where account ID, okay, so account ID is greater than this expression, which I clearly didn't copy correctly, so let me put it in again, flowvars dot last account ID. So give me only my postal codes, and once you've grabbed those max accounts, only grab ones that come in as newer accounts. So to do this, we will save our application. I'm going to run it in normal mode this time because it'll just be a bit easier for me to trace. And I'll double click on the console so I can see it full screen once it starts up. Okay, now on the first trigger, you can see it polls no problem. And now if we wait for more than 5 seconds to go by, we can see that it still is polling, but effectively is not getting any values because, again, it's using the watermark in our query. So in this case, with no values returned, it's also not updating the watermark. Now, interestingly enough, if we were to even restart the application right now, we still would not get that updated value. Recall that the watermark is persisted, even in Studio, since it is effectively an embedded runtime. So in order to be able to restart back at square one our default expression, we'll have to change our run configuration just a bit. I'll double click on the console here and stop the app. If we right click on APDev examples and go to run as Mule application configure, if you scroll down in the general tab, you'll see a clear application data option. In this case, we'll hit prompt, so that every time our application starts, we'll be asked if we want to clear out the application data. This includes things like the watermark value. So if we apply and run, we'll get the pop-up of whether we want to clear data. Let's hit yes. And once we have successfully cleared the data and the app is started, it should once again start at square one, meaning it will pick up that first record, as it has done here. And then in the next 5 seconds, again, it will show up as empty. So each time I start, I'll be prompted to restart the watermark if desired. Now, we're going to do a lot more with this flow soon, but for the time being, let's stop it its current state so that we can dive a little bit deeper into some other areas and this won't get in the way. To make sure that this flow can still stay around but be stopped, we can stop our runtime, go to the flow itself by selecting it, and set the initial state to stopped to ensure it does not trigger every time we turn Mule on. This is just temporary as we're going to dive deeper into this use case. After saving the application, let's go ahead and hop back into our next section and we'll continue talking about some of these different connector endpoints.